it's here, which statements, number 4, which statements about subatomic particles are true? So which of the following here is, we're looking for a true statement. So A says that if a atom has equal number of protons and electrons, its charge is neutral. So if protons equals electrons, if actually, let's say number of protons, n protons equals n electrons, then charge is neutral. So that's our first statement. B here, electrons are attracted to protons. Electrons are attracted to protons. C states that electrons are much lighter than neutrons. Electrons are much lighter than neutrons. And D states that protons have twice the mass. Protons have twice the mass of neutrons. Okay, so I have 4 statements here. So let's check all 4 statements. So we're looking for which statement about subatomic particles are true. So it says if an atom has an equal number of protons and electrons, it will be charge neutral. This here is true, right? For example, I have my, let's look at pick honestly any element in the periodic. Let's pick lithium, for example. Lithium has in lithium I have here is 3 protons, because my atomic number is 3, right? My atomic number here is 3, and I also have, if I round this to the nearest whole number, this is atomic number of 7. Sorry, atomic mass of 7, which means I have a neutron. My number of neutrons here is 4, right? But I don't really care about the neutrons. 4 neutrons, and then 3 electrons, right? So which means my number of electrons equals number of neutrons, and my lithium here, the charge is neutral, right? So this here, A is correct. Anytime we have number of electrons equals number of neutrons, the charge is neutral. So this is correct. B states that electrons are attracted to protons. This here is also, it's a true statement. And in the sense that this is also a true statement, is because I'm going to use this topic of effective nuclear charge. When we're talking about atomic radius in grade 11, we talked about this topic of how if there's electrons, when we're increasing atomic radius, when we're talking about going from across a period in the periodic table, so across a period here, we said that atomic radius decreases, right? Because as I expand or as I increase the number of valence electrons, my protons are attracted to electrons, right? And it's going to pull them in closer, therefore decreasing atomic radius. So by that logic, well, we can say that B is also true, right? Because I'm saying here, and I'm using this logic of atomic radius decreases as I go from period left to right, right? From left to right. Sorry, this is really bad, right? From left to right on a period, right? So again, this here, atomic radius decreases, right? Because again, the attraction between protons and electrons are basically they're intensified, and what the protons do is they drag they're more attracted to the electrons, so they drag them into the center, therefore decreasing the atomic radius. So B is also true. C here is electrons are much lighter than neutrons. This here is also true. And when we're talking about electrons being lighter than neutrons, we can actually look at the mass, right? And basically the mass of the atomic mass, when we're talking about atomic mass, we have hydrogen here, which has atomic mass of 1, and our proton has an AMU of 1 as well, right? So this here is 1.008, and electrons contribute very, very little to the atomic mass, right? In fact, the mass of an electron, I believe it's like something like 10 to the power of like negative 34 or something. And I can show you what a mass of an electron is. Here it's like 10 to the 31. So 9.11 times 10 to the negative 31. This here is the mass of an electron. And this here is much, much smaller than a mass of a proton, right? A mass of a proton is much, much, much bigger, 10 to the 27, right? So again, this here, electrons are much lighter than neutrons. This here is correct. And again, neutrons and protons have about the same weight here, and which means D here is false, right? So protons have twice the mass of electrons. This here is false because neutrons basically have the same mass as protons in that. So in this case, 4 of the statements are true, right? So this here, I'm not going to summarize this. So it says here, what is it? Answer A here, atomic mass is true for subatomic particles. That's good. B here, electrons is true for subatomic particles. Okay, C says it's true. D here is false. And then they explain it. And they said protons and electrons have opposite charge with equal magnitude. That's good. B says the opposite charges attract each other. That's good. C here says mass of electron and mass of neutron. So the mass of neutron is much higher than the mass of electron. Good. And D says the mass of a proton is twice as as heavy, or twice the mass of a neutron. Proton and neutron is similar masses. Okay, this here is a great solution. I'm gonna say but poor formatting, because they could have formatted their answer much better. But poor formatting. But poor formatting in creating an answer, because it was just like a block of text, right? Like I don't want to read this. Like it's a block of text. So I wish they had made like paragraphs or something, so this makes it easier for me to read here. So a solution here is